What's up, world? What's up, LO students, and all other programs are welcome. Today we're gonna go through trigonometric identities using double angle. As you remember, so double angle is the argument of trigonometric function, might be for sine, for cosine, as well as for tangent and cotangent. It doesn't matter which function you use, there's gonna be the formula that allows you to convert double angle formula into single angle function. All right, and as you remember, in the previous video we actually discussed which formula very useful, how to apply different variations of cosine 2x and sine 2x. And for those who skip this video, I encourage to watch that again, and maybe you'll find out much more interesting ways how you can rearrange the formula in order to apply for your specific case. All right, but for those who are still who have no idea what it is, I just remind you guys that it's all about cos 2x formula and sine 2x, and I just briefly expand it. It's gonna be cos squared x minus sine squared x. That's for the top one, it's cos 2x, and that's gonna be 2 sine x cos x. As you can see here, the double angle trigonometric function is converted or is transformed into the single argument function like sine x and cosine x. And if you want, you still be able to express through one single trigonometric function, which is very useful when you're trying to solve trigonometric equations. So today's target is to go through the problem 1. Hope you enjoyed the previous videos that were about formulas, and actually in the end there was a brief trailer for dance channel. Hope you also watched that and like this video, and we're gonna go to solve this problem. All right, tangent 2x, how we can actually prove that it's gonna be equal the ratio of 2 tan x over 1 minus tan squared x. Okay, of course, that might be the formula that you probably be given already, but again, it's all about proof, and you need to be able to do that from scratch, because you need to actually keep in mind only those two formulas. Additionally, with trigonometric equation, which is the basic one, sine squared x plus cosine squared x equals to 1. Basically, this might be a result of Pythagoras theorem. Is you just open, the unit circle, you actually see that as the Pythagoras formula for the triangle with the radius, basically with their position vector that's turning and making the circle of the length of 1. Okay, that's the straight result. Okay, so bear in mind those formulas, you need to prove that. Let's go. Tangent 2x, just by definition, is going to be sine 2x over cosine 2x. Okay, our purpose is to come to the tangent, but before I just would like to apply those two formulas here in order to transform sine 2x and cosine 2x. So I'm going to write that finally tan 2x is going to be equal to sine x cosine x and over. So here I can write actually both, and I would like to do that right now. It's going to be cos squared x minus sine squared x by definition. All right, now you need to have a look here, because actually you need to see the target thing where you need to arrive to. Okay, so you see that tangents stay on the top, and right now you have sine x cosine x. How to transform into tangent? Obviously you need to divide everything by cos squared. So that's why, from seeing that the numerator of this fraction is 2 sine x cosine x, just try to divide by cos squared x, the top side. So that's gonna be sine x over cos x, because 1 cos x will be cancelled. But because you divided the numerator of the fraction, you need to do the same with the denominator. If you divide both numerator and denominator, in the denominator you'll get 1 minus sine squared x over cos squared x. And now from here you can say that tan 2x is actually 2 tangent x because of that, and in the denominator is going to be 1 minus tan squared x. And as you can see, it's not really hard if you actually see what you need to arrive to, and you need to arrive to the single trigonometric function. So that's why you can do that just simply by dividing numerator and denominator by the same divider. In this case, it's going to be cos squared x, because you definitely know that you need to get a tangent in the numerator. All right, so that was pretty easy. However, in A level, this problem is marked as, kind of P problem or EP. Actually, I see no difficulties here, but maybe for some students, it's going to be a useful example. Okay, hope you got it, and we'll move to the next problem.